a privilege and honor to have been taught my trade, which built my skilled career by the sacrifices and with the integrity of all the veterans, my supervisors, other journeymen, and fellow apprentices during my 15 years in naval ship repair. The time shared with the active duty personnel working together to keep our fleet in tip-top shape encouraged my understanding of why we are a nation with freedom and open dreams that can be reached with our own hard work. Ladies and gentlemen, welcome to my job shop. My name is Keith, and I'm here repairing America one project at a time. Are you ready to get back onto our brazing job? All right, I just want to kind of run through my setup here so that you didn't miss anything. I brought out my little well positioner and got it set up on the table, and this gives us really any tilt, angle, speed, and all the adjustments that we need. I a long time ago took a 4-jaw and made a little plug here that fits into the register on the plug and the 2 screws right here, and I tapped 2 holes into this plate right here. The 4-jaw is the most universal chuck there is, and it gives me a lot of opportunities in here. I've even done really long shaft weld positioning shafts, like weld fusion overlay process on some of my marine shafting. I should be saying, in my earlier videos you can see a lot of those, and I used to set it up in the other table on my really long blue metal table. So I've got this set up here because I'm going to take our part here and I'm going to actually set it up in here so that I can tilt it down and move it around. But before I do that, we're going to go into the Rutland lathe and I'm going to machine a piece of graphite so that I can insert it into the bore so I can maintain the roundness of the bore, the true roundness of the bore, while I weld or braze that material in. Graphite material comes in all different shapes and forms, and you can pick it up. The quickest place is Mink Master Car. And also too, I'm going to be using, just because everybody always asks, borax number 2 flux. And the rod I use is just low fuming brazing rod. Alright, that's the general guidelines for any heavy brazing that needs to be done for the ultimate maximum strength to match the cast alloy. Alright, let's take this in, go into the Rutland and machine this to fit that bore right there. We've already kind of cross-mic'd that bore, and it's a little bit larger than nominal, and we're also going to be miking the actual shaft that goes through there, and I think it's going to be the nominal. So let me meet you in there. Okay, we get anywhere from 263 to down to about 258 or so for the bore. The bearing diameter on that shaft is right at 250, 250, meaning 1.25 inches. And the threads themselves are actually turned down. They're like 230 or so. So that's why that's able to just slip right in there. All right, this piece here was turned originally for the last project we used it for right at 1.5. We're going to barely put this in here because we want at least that amount of stick out so that we can turn a diameter there. Okay, and runs real true. I like that, and this chuck is really lightweight as well. I'm going to run my vacuum, but I'm also, just because the way graphite machines, I'm just going to protect that a little bit. And we're going to turn the outside here. Let's see. give it a little light here so I can see where I'm going. Okay, just touching. So we're going to set that at 1.5. And 0 on the length. Now I'm running the vacuum here just because keeps the shop clean, my machine clean. And graphite's real black stuff. It likes to stick everywhere. Oil, rags. Okay, base cut. We already know we set it at 1.5 inches, so we're going to go ahead and okay, there's 450. That'll be 50 thousandths off the diameter. Huh. When we were grinding the last time, I left it in reverse. There we go. The stuff is so light, you don't have to have the vacuum right on it. It's sucking it from that far away. I know you're not on the right side to see the bit cut, but you can see the beginning of the material coming off. Okay, that's something we can work with right there. It won't come off by sliding it. You have to slide it all off the end, meaning it's not going to come out of that opening. So we got more than half the bore right here. Okay, let's go braze. All right, I just took this from the sandblast booth because I gave it a real quick once again blast, and there's our slug right in there. Now I kind of preset the jaws in here, and it rests on these two ears out here and tightens on the inner web. Got this down in position here so that I can work on it. I added one blanket around the chuck area. The reason why I do that is because it's going to suck some heat as it is, but once it sucks so much heat, I want it to hold so much heat. I want the control so that the heat is not being drawn away. So once the heat's right here and out in the open there, it's not going to be traveling so fast. It's going to take a while to warm this thing up, to get up to temperature and everything else, because you can't. The number one mistake on brazing is thinking that you're going to go ahead and melt that rod and go, and you're not. You've got to get this base material up to the working temperature of grabbing a hold of the flux. After it grabs a hold of the flux, then you bring it to another heat temperature, which is a few degrees more, and then you are starting to be able to melt and actually flow molten braze onto it, and then you can go from there. All right, I'm gonna go get a drink before I get started here. Some more water and an iced coffee, and I'm gonna get you your proper lenses and your proper position so that you'll be able to see me do this as best as I can allow you to see it. I'm going to give you that full opportunity to watch me braze this up. Pretty cool. I've got you set up in position because I'm going to be brazing like this. Actually, that light looks a little bit. I have a new attachment here and add a little tinning. Okay, that looks pretty good. This is not so glary now. All right, so I'm going to be brazing right here. Now I'm going to be able to zoom you in a little closer, okay, when we get going. But right now I just want to make a few tests here, because once I strike the flame here, kind of watch how sensitive this is. Okay, I'm just gonna strike acetylene. Okay, look at that flame. Add oxygen. Reduce oxygen. Add oxygen. Okay, we're having fun now, right? Okay, put it on pause and pee now if you have to. Sometimes you benefit of having a friend with another torch. He can help preheat it, and if your project's big enough, he can help keep it hot all around the area that you're working. Main reason why you're getting everything all hot and everything so it's uniform, the part expands all equally, and then your added material and the cast material will contract and shrink at the same time. I could have pulled that plate off the back. I'll bring you back in when I got it hot enough to start. Okay, we're getting a little closer. I wanted to say that my mixing barrel, my new one that I exchanged for the one that I'm actually holding now when I was back over at the other place, was clogging up on the acetylene. I pulled out the spark arrestor and it was real dirty and everything else in there, so it started clogging itself up and it wasn't letting it flow. So I changed back over, and this mixing barrel's got the old spark arresters mounted on the back side there, And actually, I like it because this thing is like balanced in my hands. I forgot how nice I enjoyed this. Also, it lets a little bit more fuel flow through, and I can run my rosebud and my bigger tip with a much better control and less overpowering the mixing barrel. Okay, we are getting close. What I want to see is how fast I can get that to glow red. See how that? Okay, when you get it to just be able to start turning red real quick, okay, you know you got a good preheat on there. Alright, I'm just going to go around a couple more times here. And then we're going to grab my rod. Then I'm going to talk about fluxing. Some people like brazing flux with flux on the outside of it. I learned to braze without that. I braze with adding flux. Not every dab of your bead is going to need flux. You can braze on top of braze with no flux. So you don't always need flux. So why have it on every single piece of rod? That's my thinking. My personal preference is no flux on the rod. I like to add it myself. Okay, I'm going to bring you in close. Okay, I preheat my rod. And then I got my coating of flux. See, you get it when you want it. Okay, now first off, I want to tin with the flux on the surface. See, I can get that molten red all around there, and now I want to start fluxing that. I'm not trying to braze right now. I'm just trying to spread flux, and that preps all of that surface that I'm going to try to braze there. Okay, now I can start brazing. Your first layer is the most important there. You got to get it stick on there like that. And you want it to flow right in against that graphite right there. I'm just going to go up the wall right here a little bit. I can rotate it down a little bit. That'll be helpful. What's nice about the well positioner. Okay, that surface is tin. Let's go for the other one. When I say tin, I meant the first layer actually being on there. And happy with that. Okay, preheat our flux. Add our flux. Okay, get it ready, and then braze. You control the heat of the part with the bottom of your flame, and you control the melting of the rod with the upper part of your flame. Okay, now we can just start adding on there. We don't necessarily need flux on here all the time. Turn down the flame just a little bit so it's not so aggressive. Okay, I'm going to want to go back the other way a little bit here. There we go. This is more so a winter job. But people always think about working on their projects during the beautiful season. Now we're not necessarily going to worry about the laps on the top or the bottom or the inside there just yet, because we'll be able to tip it up and we'll be able to do some filling in with that later. Kind of like drip castles. That rod was getting too short for my hand. Okay, I'm gonna be in here a little bit. I don't know if I'm in your way or not, but maybe not. All right, I think we got a pretty good bridge there. Okay, let's bring it back, and we got to continue this wall straight up here. All right, I just kind of leveled it off a little bit here. Okay, you can see that, you know, I mean, every once in a while I add a little dab in here. You got very little bit of filth or interference with brass to brass. Okay, there's a little tiny low right there. I'm just going to try to fill that in. There it goes. Okay. I was taught the gas weld at the age of 7. I was getting pretty good at it by the time I got to 10. Okay, this really starts ramping up now, so you can always take a rotary burr and you can always remove some brass. So if you need more, or you think you want more in an area, put it there. Up. Sometimes you lose it, but hey, you're the one that controls the torque. You learn where the heat circulates from the back port there too. Okay, I got a wire brush here because I'm just going to knock some of the little bit of dirt that's on the top. Getting pretty close to being square. Okay, I'm going to come over here and work this wall straight up, other direction. Okay, sometimes you got to switch hands. It's actually easier to do a vertical with braze than it is to go downhill, so. And working your edges first. And on the overlaps on the outside, if you can get brazing to stick to the, it actually kind of really seals that end seam or the end surface, whatever you want to call it, the mating surface. Okay. Okay, and this is that surface right there that we were just telling you about. Go ahead and walk it right on over a little bit. Okay, now I'm going to get this face here. Okay, I'm gonna pop it out of there real quick, and then I'm gonna turn it up on its end, and I'm gonna smooth out the braze on the inside. I might be able to do it all the way down. No, it's not gonna. Okay, I'm gonna shut off the torch for a minute. It's not gonna happen that way. Okay, I gotta pull this off. Okay, undo my chuck. Okay, and get a big pair of pliers. The chuck's hot, so I'm going to keep it up here. Oh, I kicked the cord. Okay, now we know we're safe. Okay, I'm going to move you over to the other side because I need this angle here to get in here. Okay, that's almost perfect. All right, here we go. Okay, I think we're starting to get it warming up. It's freaking hot in there. Sometimes you got to get in there and you scrub it a little bit with your rod. You got to make sure that you're getting. Yep, that's excellent, excellent. That's what I'm talking about. Yeah, see that ramps up? That's got to ramp up. Okay, got to make sure you get this area back here. Can't let that void. That's actually probably helping. That'll help hold that radius up there. Get some flux down in there. That rod is too damn hot. There you go. Okay, now we know we got enough material for that ramp. And enough material out here to come out to a sharp corner. That's my all. All right, we're gonna let this cool down slowly. And we're gonna go edit this footage and stay tuned for the next video. Get her done.